Hello and welcome into the content video for lesson 15 for Precalculus 2. In this video, we are going to be talking about polar form of complex numbers. So if you recall, and I'll kind of talk as I'm sharing the document camera here, we started out when we were talking about polar coordinates, relating it to rectangular coordinates, our rectangular coordinate system. Here, we're going to be relating polar numbers to our complex numbers. So if you recall, a complex number is written in the form a plus bi, where a is the real part and the sign with the b, so plus b minus b, is the imaginary part. And we can graph these, right? It's just instead of an xy axis, we have an AB axis. And so given this, if I have some point in the AB plane, I can do what? I can draw another triangle like we've been doing all semester, right? And so this line here going out is no longer called a hypotenuse. It's no longer called, what else? The radius. It's now called, because we're dealing with complex numbers, the modulus. Excuse me. But our calculations are still the same. So we have the modulus. If we have a complex number z, which has the form a plus bi, then the modulus of z, the modulus of this complex number, is the square root of a squared plus b squared. Again, just like we've been doing all semester, hypotenuse, radius, etc. Once we have this, once we calculate the modulus, we're then able to convert a complex number into a polar number as follows. So a complex number z equals a plus bi, excuse me, sorry, has polar form z is equal to r times cosine of theta plus I sine of theta, where r is just equal to the modulus, what we just found, right? Square root of a squared plus b squared. And tangent of theta, again, like we've been doing all semester, is b over a. And so let me get out my red pen again. And I know I keep doing this in these videos, and then we come to class, and it's like, wait, why isn't my theta working? And I'm going to tell you, theta must match the quadrant of the complex number. So if the complex number is in quadrant 3, the theta you pick has to be in quadrant 3. That's, again, still all the same stuff that's been going on all semester. What's up, Katie? Got my little helper with me here tonight. So that's how we can convert complex numbers into polar form. Once we have them in polar form, we have multiplication or division of complex numbers. So we have the following. If two complex numbers, z1 and z2, have polar form, I guess technically polar forms, where Z1 is equal to R1 cosine of theta 1 plus I sine theta 1. And you will notice, and I should probably go back here to the general form of a complex number, these thetas are the same. So if you write out a polar form and you have like pi over 6 here and pi over 3 here, it's wrong. It's got to be the same value, right? Because we calculate it the same. So in this situation, these thetas are the same. And then Z2 is R2, because that could be different from R1. And then cosine of theta 2 plus I sine of theta 2. So Z1 and Z2 are polar numbers, so they could have different R's and different thetas. So if we have that, then Z1 times Z2, the product, is equal to R1 times R2. And this is multiplied by cosine of, add the thetas, theta 1 plus theta 2, and I sine theta 1 plus theta 2. If I am dividing Z1 divided by Z2, well, it's just R1 divided by R2. And now instead of addition, it's subtraction. So cosine theta 1 minus theta 2 plus I sine theta 1 minus theta 2. And then last but not least, and again, this is the content video. So this is just me giving you all these formulas. And then in the example videos, we'll go through a couple examples and convert complex numbers into polar numbers. We'll do multiplication, we'll do division. So we'll go through all this so you can see how the numbers work out. But the last thing we're going to talk about is what's called DeMoivre's theorem. And this is when we have a complex number raised to an exponent. So if I have, for example, a plus bi to some exponent n, then this says that if my z, my polar form of this complex number, is r times cosine of theta plus I sine of theta, then for any integer n, and an integer is what? Is a plus or positive or negative number. So for any integer n, then DeMoivre's theorem says that z, that complex number to the nth power, is my r to the nth power, and then cosine of n times theta plus I sine of n times theta. So that's it. Kind of quick to the point. So this video, again, it's a bunch of formulas kind of thrown at you. I get it. Copy them down, make sure you have them correctly, go back, double check if you need to, because if you have it wrong, your life's going to be a nightmare when we start calculating and converting these things. This is kind of short, sweet, to the point. The example videos, that's where we're going to do all the hard work. So come on back and we will look at examples for lesson 15.